The Oki Islands are an archipelago of 38 islands located in the Sea of Japan, 40 kilometers north of the nearest Japanese mainland in Shimane Prefecture. The 4 inhabited islands are divided into 2 districts: Dozen, which is nearer to the mainland and consists of the islands Nishinoshima, Ama, and Shibu, and Dogo, the larger round island 10 kilometers northeast of Dozen. The land on the island includes mostly forests and mountains, followed by agricultural land, roads, and residential areas. In September of 2014, Japan and UNESCO designated Oki as a national geopark due to recognition of its natural beauty, unique geophysical conditions, as well as its geographical significance. The sea, although beautiful and a great source of industry, isolates Oki from the rest of the country, with only one daily ferry to and from the mainland. This isolation has led to an expensive, fossil fuel-dependent power grid for the islands, and fewer commercial prospects for its denizens. Since 1955, the population of Japan has increased by 40% as a whole, leading to sometimes unfathomable congestion. In stark contrast, the population of Oki has halved over the same time period. As Oki's population has declined, so too has its economy. Fishing still provides the largest share of production and will probably always be significant, along with agriculture, which primarily consists of rice. Being remote islands, Oki's geographical loneliness has become a barrier to economic development, especially transportation cost. The primary sources of electricity are 2 oil-fired power plants, the Kuroki power plant on Dozen and the Saigo plant on Dogo, connected by a 22 kilovolt submarine power cable named the Saigo-Kuroki cable. The operation of the plants depends on the continual ferrying of petroleum between the Japanese mainland and the Oki Islands.
The University of Texas at Austin has worked with the Graduate School of International Development and Cooperation at Hiroshima University for over 10 years, and we have gradually attempted to integrate our students into joint projects. Recently, IDEC has begun to plan each summer a course that would involve students from both the University of Texas at Austin and 1 or more universities in Japan on some joint research project. This past summer, they were able to obtain funds from the Japanese government to support 10 students from the University of Texas at Austin going to Japan to work on issues of renewable energy in the Oki Islands. The rationale for the project was to see whether or not students, along with faculty, could investigate options for investment in renewable energy on the Oki Islands, and by having that experience, be able to enhance their confidence as professionals being able to solve a challenging sustainable development project.
The islands currently have some renewable energy generation installed in the form of wind turbines and solar arrays, as well as 1 hydroelectric facility. Whenever a large portion of a grid's energy comes from variable renewable energy, large amounts of energy storage become necessary, but these have already been installed in the form of large lithium-ion and sodium-sulfur batteries in the Dozen district. While there is a plan to install more solar capacity at the Okinoshima airport, open lands for further solar installation will be at a premium. Additionally, the large amount of cloud cover over the Oki Islands leads to very low solar insolation. The sun shines only 19% of the time over the course of the year. Overall, the Okinoshima municipality rated the island's total solar resource at only 2.4 megawatts unless large sections of the forested geopark are cleared. Fortunately, there is a much higher capacity for wind generation. Several turbines have already been installed, but only a small part of the archipelago's total wind resource have been tapped. The research team went to work calculating what it would take to satisfy the remaining renewable energy needs with wind.
So we're trying to calculate the number of windmills. And the number of windmills essentially depends on two things: the energy generation from each windmill and the energy demand. And the energy demand we know from the historic load profile, which is about 24 megawatt at any particular time throughout the season. 24 megawatt is the maximum. We've seen that Oki Island consumes about 79 million kilowatt hours in a year. And the energy generation of a windmill is dependent on the air density, the wind speed, and the swept area of a windmill. And the swept area we've calculated by a model that Okinoshima is already installing at the island, and that has a blade length of about 42 meters. And we've seen the historical air density by the change in relative humidity and temperatures. To calculate wind speed is a more challenging task because it varies daily by every hour in a day. And for that, we have actually we've developed the probability distribution of wind speed in any particular hour and in a day, and we've simulated it over a case year with Monte Carlo simulation. And the probability distribution is done by fitting a Weibull distribution graph on the historical data. And for that, we need two parameters. We need the scale parameter and the shape parameter. And we've used their historical data to calculate these parameters. And from that, we moved upwards. We calculated the ideal graph, which is something like this, the ideal graph of the probability distribution. And from that, we did a Monte Carlo simulation for the whole year. And then we saw how much power is generated in a year, in a day, and in every hour. And from that, we calculated the total generation, and that which we matched to the demand, and that helped us calculate the number of windmills.
The exact number of windmills will depend on the availability of space to place them. Limiting our analysis to Dogo, where roughly 80% of the population live, we started by comparing the maps of wind intensity to the maps of human activity and land utilization. Most of the zones with the most productive winds, the red grid squares on the map, are unavailable because of the island's parks or unsuitable because of poor soil characteristics. Because wind turbines remove energy from the air, placing them too closely together limits their effectiveness. We found the total number of turbines that would be required by filling the highest productivity zones first. With a 200-meter buffer between the turbines and the parks and human settlements, 26 turbines will be necessary. If the community desires a larger half-kilometer buffer, 6 additional turbines will be necessary because more low-productivity areas would have to be used. For our economic analysis, we used the worst-case scenario in which 32 turbines will have to be installed.
The cost-benefit analysis goes through two scenarios. One, where we maintain the status quo, continuing to import heavy oil and burn it in what is effectively a diesel engine to generate electricity. And two, where we will install 100% renewable energy capacity. In the first figure, you can see the projected price of heavy oil from 2015 to 2040 as based on estimates from the World Bank. The second figure projects the cost of operation for the heavy oil plant through 2040. The third and fourth figures show the cost of installation and the cost of operation of the recommended amount of solar photovoltaic technologies. The fifth and the sixth figures show the cost of installation and operation for the recommended amount of wind turbines through 2040. The seventh and eighth figures show the cost of importation of the heavy oil to the Oki Islands and the operation of the fire power plant in the event that Mother Nature does not comply and the renewable energy sources are not sufficient enough to provide the electricity needed by the residents. So in the next two tables, you'll see the total cost of the first and second scenarios. The first being the cost of maintaining the status quo and only generating electricity from burning the heavy oil. Two, you'll see the total cost of the installation and the operation of the renewable energy technologies as well as the importation of the reserve heavy oil and the operation of the fire power plant. Based on the assumptions that we've made in this study, it can be seen that the implementation and operation of the renewable technologies is drastically cheaper than that of maintaining the status quo.
Our recommendation, then, is to finish building out the accessible solar resources and to meet the remaining gap with wind power. As an island community, Oki's wind profile is closer to offshore installations, which match demand profiles better than typical wind projects. The installed storage capacity will help smooth the renewable energy generation with demand, but the oil fire plants, which are in good working condition, will cover the few remaining gaps. The Oki Islands can become a lab for renewable energy implementation and make the geopark a testament to sustainable development.
One of our main recommendations is to focus on a renewable energy portfolio that consists mainly of wind and is complemented by distributed solar generation from residential rooftops around the island. And then we will also likely recommend that the Oki government keep up and maintain their oil-powered plants as a means of backup in times where renewable energy or renewable power isn't available. So I think this research sets a great example for other developing areas, especially remote areas. As the rest of the world develops and begins to electrify, we need to be able to make sure that we are implementing electrification strategies that are responsible and sustainable. And I think this project will go a long way in setting an example for that.
Our findings will really help give local government a new perspective and good examples of what has been done here and how it could help them there, as well as just us being able to assist them in their analysis for really figuring out their resource mix and feasibility for future projects. And I really hope that it will help them with economic growth and getting people back onto the islands.
It was very impressive that the municipality of Oki and Shimane Prefecture are putting so much effort to revitalize the island. And I think our work is to assist their effort. So with the support from their local governments and from our side, I think we could see the possibility that the 100% renewable energy island was feasible. So I think that could be the conclusion or the possible outcome of this project.